Erosion is common everywhere around the world. It's the gradual removal of sediment and its consequent transport to another site. When it happens on the shore, we call it coastal erosion, and it's mainly caused by wind, currents, and waves. Different factors influence the erosion rate on the shore: the size of the settlement, the degree of exposure to waves and currents, human development, and vegetation, to name a few. We are interested in studying how underwater shapes and vegetation affect wave and current flow and how it modifies the transport of sediment. Underwater shapes with uneven, rough surfaces formed by benthic organisms, the ones found on the seagrass floor, are collectively called canopies. Coral reefs, mangrove tree roots, kelps and seagrass are all examples of canopies. Now, imagine you're standing in the middle of a dense forest on a windy day. The trees surrounding you affect the wind, reducing its speed and strength. You're protected. If you're standing in the middle of an open field, on the other hand, there's nothing to protect you at all, so you feel the wind stronger. The same thing happens underwater. Past researchers have shown that the presence of canopies have a profound impact on protecting the shore. As water is what transports sediment, its distribution is affected too. So, canopies change the way sediment is transported, but sediment also plays an important role in maintaining a canopy's health. In seagrass meadows, sediment deposition is good. It prevents scour, decreasing mortality and promoting community growth. In my research project, we want to understand how canopies affect waves, currents, and sediment distribution on coastal regions by comparing their behaviour in exposed and sheltered environments, and ultimately come up with a formulae and generic description. We know that in exposed environments, waves and currents are strong enough to suspend and carry sediment, but what about in sheltered environments? To find out, we submerged some equipment in Cockburn Sound along the coast of Western Australia to measure the currents, the waves, and the suspended sediment concentration. We chose this place because it's very sheltered, small waves, small currents, but also has a very strong sea breeze with direction and strength varying throughout the day. We left the equipment in the sheltered bay with a dense seagrass meadow for a week, and then moved it to a bed with no seagrass no more than 30 metres away. This meant we could ensure similar wave and wind conditions. We noticed that over the seagrass meadow bed, the sediment concentration didn't vary much. Over the bare bed, however, smaller waves could suspend more sediment. We also found that wind speed and wind direction could change the concentration. Winds blowing from the south, albeit stronger, wouldn't suspend the sediment. Winds blowing from the east were weaker, but still more capable of resuspending it. The research is ongoing, and we hope to better understand nearshore dynamics, develop new formulations, and a better understanding of nature processes, thus helping decision makers around the world.